So let's go over modern JavaScript classes, which is syntactic sugar over prototypical inheritance. In modern JavaScript, the class syntax provides a cleaner and more intuitive way to define constructor functions and manage prototypical inheritance. This new syntax simplifies the creation of objects and their prototypes, even though it is essentially syntactic sugar over the existing prototypical inheritance model. This syntax, introduced in ES6, which stands for ECMAScript 2015, is part of a specification that enhances JavaScript by adding new language features to modernize it. So consider the traditional constructor function for a programmer that we've been working with. So if I use the function keyword and I name it programmer, I specify two parameters, name and preferred language. Then I set the properties with the this keyword. So this.name is assigned to name, and this.preferred language is assigned to preferred language. Now to create a method, I'll use the this keyword, and I'll name my method code, assigning this to an anonymous function. So let's log to the console, backticks, this.name is coding in this.preferred language. So now I can create an instance of this with the new keyword to create a new object in memory. So I'll say const programmer is assigned to new programmer. I'll pass in my name, Steven, and the preferred language is JavaScript. So now I can call programmer.code, and we can output that to the console. And here we see our expected console log statement. So let's rewrite this constructor function using modern class syntax, which makes it clearer and more structured. So we can comment this out. So this is the syntax that you would use in modern JavaScript applications. You would use the keyword class, and then you name that class. So in this case, it's programmer. And now you would define a constructor function. So classes in JavaScript have one constructor function, and this is the function that is called when you use the new keyword. So it is named constructor, right? So that's the keyword. And in this case, the parameters are name and preferred language. And within it, we set our properties. So this.name is set to name, and this.preferred language is set to preferred language. So now to define our method, we'll name it code, and we will log the same output statement. So let me just copy it here, just to save us some time. So this is the modern way to define our classes in JavaScript rather than using constructor functions. And when we save it, we will get the same output. Right, so once again, we get Steven is coding in JavaScript. So understanding the underlying functionality. Despite the use of the class keyword, the underlying mechanism remains the same. So consider the type of operator. Even with the class syntax, programmer is still a function in terms of JavaScript's type system. It's specifically a constructor function. So let's log that out so I can demonstrate that. And then I do log, and then tab. If I do type of, and then programmer, we will see that the type is a function. So when we save this, we see that it is a function. ES5 compatibility. For environments that do not support ES6 classes, tools like Babel, available at babeljs.io, can transpile this modern JavaScript back to ES5 compatible code, ensuring that the classes work across all browsers. So consider the benefits of using class syntax. The first benefit is clarity and simplicity. The class syntax is easier to read and understand, especially for developers coming from other object-oriented languages like Java or C#. The second benefit is encapsulation. Using class syntax encourages better encapsulation and a more declarative structure for defining object constructors and methods. And the third benefit is standardization. It offers a standardized way of object creation and inheritance that aligns with other programming languages, easing the learning curve. So in summary, by utilizing modern JavaScript class syntax, you could write cleaner, more maintainable code while still leveraging the powerful prototypical inheritance model that JavaScript offers. This approach not only enhances readability, but also simplifies complex coding structures, making it an essential skill for developers working in modern JavaScript environments. How does the class syntax in modern JavaScript improve the process of defining constructor functions and managing prototypical inheritance? The class syntax in modern JavaScript makes it easier and clearer to create objects and their prototypes. It provides a straightforward way to define constructor functions and methods, making the code more readable and organized compared to the older method. Even though it looks different, it still works the same under the hood. What are the benefits of using class syntax over traditional constructor functions in JavaScript? There are three main benefits of using class syntax over traditional constructor functions in JavaScript. The first being clarity. The class syntax is easier to read and understand. The second benefit is encapsulation. It helps organize code better by keeping related methods together. And the third benefit is standardization. It aligns with how other programming languages handle classes, making it easier to learn and use. So for your exercise, update this function constructor to use the ES6 class syntax. So here, I'll call item.display, and I get the output of the name of the item and the quantity. So to implement this, I'll comment this out. So now I'll do class, and I'll name the class grocery item, then curly braces, and then I'll define the constructor function, which will be executed when I use the new keyword. So the parameter is the name and the quantity. And I just assign this with the this keyword to set the properties and for the quantity. Now I'll define a method. So I'll say display, and I'll just copy this console log statement and paste it here. So let's clear our console, and I'll save it, and we get our expected output. In JavaScript, functions can be defined using either function declarations or function expressions. Both methods serve similar purposes but have key differences in behavior, particularly regarding how they are hoisted. So let's consider function declarations. Function declarations are hoisted to the top of their containing scope. This means that they are moved to the top during the compile phase, allowing you to call them before they are physically defined in the code. So to demonstrate this, I'll implement a function, I'll name it greet, and then I will log out, hello world. Now, to demonstrate function hoisting, I can call or invoke the greet method before it is defined. So if I save this, I get the expected output. So because of hoisting, JavaScript will move this function to the top of the file during the compile phase. So now considering function expressions, in contrast, function expressions are not hoisted, which means you cannot call them before they are defined in the code. Trying to do so will result in a reference error. So to demonstrate this, I'll just comment this out since we don't need it. I can say const say goodbye, set this to an anonymous function, and then we will log out goodbye. So now if I try to invoke it before it is defined, let's clear this out, and I save it. Here we see we get a reference error. So we can comment this out. So now let's apply this concept to the programmer class context. So you scroll up. Now let's consider this class that we defined in our previous lesson. When working with classes, it's crucial to understand that, like function expressions, class declarations are not hoisted. This means you must declare a class before you can instantiate it. So let me move above it just to demonstrate that we cannot instantiate it before it's being defined. I can say const dev is assigned to a new programmer. I'll say my name and the preferred language of JavaScript. And I'll just save that. And here we see we get a reference error. We cannot access programmer before it's initialized. So using class expressions. Just as with function expressions, classes can also be defined using a class expression syntax, which is not hoisted and allows for more dynamic declarations. So to demonstrate that, I'll just define this here. I can say const my programmer class, set this to the keyword of class, and then curly braces, And then I want it to have the same functionality as this programmer, so I'll just copy this over. Let's comment out this line, so we don't need that. So we've created this class expression, and let's create an instance of it below its declaration. So I can say const programmer, and new my programmer class, pass in Steven, and in this case I'll say JavaScript. And then we can call the method programmer.code. Let's clear this out, and we'll save it. And we get our expected output. So here we are creating an instance of it after its declaration. Now, if I were to move it up, so I'm moving it up with Option and up arrow, moving it up here. So now that I try to instantiate an instance of this before its declaration, if I save it now, then I get a reference error. Note that you wouldn't actually use this class expression syntax very often, but I wanted to demonstrate it just to show that it is possible. In conclusion, choosing between function declarations and expressions, or class declarations and expressions, can impact how you structure your JavaScript code. For simplicity and clarity, especially when defining constructors and methods within a class, using class declaration syntax is often preferred. However, being aware of hoisting rules is crucial for avoiding runtime errors and ensuring that your JavaScript code executes as intended. What is the main difference in behavior between function declarations and function expressions regarding hoisting in JavaScript? The main difference is that function declarations are hoisted to the top of their scope, so you can call them before they are defined in the code. Function expressions are not hoisted, so you must define them before calling them, otherwise you'll get a reference error. Why is it important to understand hoisting rules when working with class declarations in JavaScript? It's important to understand hoisting rules because class declarations are not hoisted. This means you must define a class before you use it, or you'll get an error. Knowing this helps you avoid mistakes and ensures your code runs correctly. In object-oriented programming, especially within JavaScript classes, we distinguish between instance methods, which act on instances of the class, and static methods, which are called on the class itself and are often used as utility functions. So let's consider the programmer class that we have defined. So whenever we create an instance of a programmer, it has access to the code method. So to demonstrate that, we have dev.code. When we save that, we get the expected output, which is this console log statement. So now let's define a static method, which would be accessible through the programmer class. So I'll use the static keyword, and then I'll name this method compare skill, and this will accept two parameters. So I'll say programmer1 and programmer2, and this will return a Boolean value comparing programmer1 and their preferred language, and strictly equal to programmer2.preferred language. So let's create another instance of this programmer. So I'll do Shift Option and down arrow to create a copy, and I'll name this dev2. I'll change the name to be Alice. Now, to compare it, I will log the result of that Boolean value. So let me scroll up and see better. And I'll say log. I'll do programmer. And then the static method. So I do dot compare skill. Now I'll pass in dev and dev2. And we'll expect this to be true because they're using the same programming language. So let's clear this first and then save it. So we get the output of true because they both have JavaScript as their preferred language. So let's scroll back up so we can review our class. So instance methods like code are used to perform actions that are relevant to the individual objects created from the class. And static methods, such as compare skill, are used for operations that are relevant to the class as a whole or involve multiple instances of the class, but don't depend on any single object state. So understanding the utility of static methods Static methods are particularly useful for utility functions, where the operation does not depend on the state of a particular instance, but rather on the parameters provided to the function. This makes them similar to functions provided by the math object in JavaScript, such as math.round or math.max, which perform general utility operations and are not tied to a specific object. In conclusion, understanding when to use instance methods versus static methods in your JavaScript classes can significantly impact the design and functionality of your applications. Instance methods are best for manipulating or utilizing the state of individual objects, while static methods are ideal for tasks that require a broader scope, ones that involve the class itself or interactions between multiple instances. This distinction helps in organizing code logically and maximizing the efficiency and readability of your JavaScript applications. What is the difference between instance methods and static methods in JavaScript classes? Instance methods are used on individual objects created from a class and act on the data within those objects. Static methods are used on the class itself and are typically utility functions that don't rely on the data of any single object. Why are static methods useful in JavaScript, and when should they be used instead of instance methods? Static methods are useful for tasks that don't depend on the data of a specific object, but rather on parameters provided to the method. They should be used for general utility functions or operations involving multiple instances of the class. So for your exercise, to add a static method to the grocery item class, you can define the method with the static keyword. So static methods are called on the class itself rather than on instances of the class. So for your exercise, create 2 instances of the grocery item class, and have each of these objects have different names and quantities. Then implement a static method named compareQuantities to compare the quantities of the 2 items and print out the result. So if the quantity of item number 1 is greater than item number 2, then log that the name of the first item has more quantity than the name of the second item. If the quantity of item 1 is less than item 2, then log that the name of item 2 has more quantity than the name of item 1. Otherwise output that both of them have the same quantity. So to implement the compareQuantities static method, I'll use the static keyword, and we name it compareQuantities. Then it takes in item 1 and item 2. Then I'll use an if statement. So if item 1 dot quantity is greater than the quantity of item 2, quantity, then I will log, use backticks so I can use interpolation, item 1 dot name has more quantity than item 2 dot name. Else if item 1 dot quantity is less than item 2 dot quantity, then I will log out item 2 dot name has more quantity than, let's fix this, move that y, then item 1 dot name. Else will be the case when they're equal, and log out item 1 dot name and item 2 dot name have the same quantity. So let's create 2 instances of the grocery item class. So I'll say const, I'll call this apple equals new grocery item, and then the name is apple, and the quantity is 4. So I'll just copy this line with Shift Option and down arrow, and I'll rename this to be banana. Let's just copy this over, and I'll update this value to be 7. So now I can call this static method with grocery item dot compare quantities of apple and banana. So let's save that. And here we get the expected output that banana has more quantity than apple. Let's switch these values around just so we get the expected result. We'll clear it out. And when we save it, we get apple has more quantity than banana. And in the case when they're equal, we get that apple and banana have the same quantity. Let's go over understanding the this keyword in different contexts with the programmer class. The this keyword in JavaScript behaves differently based on how a function is called. This behavior can lead to unexpected results, especially when functions are detached from their object context. So let's first illustrate this with a programmer constructor function. So we'll use the function keyword. We'll name it programmer. This accepts a parameter of name. So we'll set the name property. Then we'll implement a method named code. So we assign this to an anonymous function. Then log, and then tab. And we will log out the this keyword. So let's create an instance of this programmer object. So we'll name it programmer, assign to a new programmer, and I'll specify my name. So Steven. And then I will call the code method. So now when I output this and save it, here I see it outputs this instance of the programmer. So that object in memory. So here we see the property of the name and the code method. So now let's consider detaching a method. When you detach a method from its object and call it independently, the this keyword loses its original context. In JavaScript, functions are objects, so we know that this method, or in other words, this function, is just an object in memory. So to get access to it, I can call it detach code method, and I set this to a reference to that object, right? So functions are objects. And so now this identifier, detach code, will reference this function. However, because it's detached, it has lost context of its this keyword. So now let's invoke this. So I can say detach code. And then let me clear this out so we can see it. And so when I save it, here I see in the original instance, when I call code, it logs out the programmer object. However, when I call detach code, it logs out the window object. So in web browsers, the this keyword will reference the window object. And in Node.js, it will reference the global object. So how can we fix this? We can utilize strict mode. So we go up here. In JavaScript, strict mode changes the behavior of the this keyword in function calls not associated with an object. So in strict mode, the this keyword becomes undefined instead of defaulting to the global object. So if I were to use strict as a string, ended with a semicolon, and I would specify this to be the first line in the program. So now let's clear this out. And when I save it, the first time when I call the code method and it console logs the this keyword, it references the current object that it's referring to. However, in the case when we call a detach method, previously it was referencing the window object, but now since we're in strict mode, it outputs undefined. So here we're using a constructor function. Now if we were to use classes, they implicitly use strict mode to avoid these issues. Instead of using a constructor function, I'll specify it to be a class. So define the constructor method. This sets the name property, and I'll define a method for code, and it outputs the this keyword. So let's comment this out. So we don't need to explicitly specify use strict. Let's clear this out. And when we save it, so because we're using the class syntax, it is implicitly using strict mode. So let's cover the benefits of strict mode in class bodies. The first benefit is safety. It prevents functions from unintentionally modifying global variables, which can lead to difficult to track bugs. And the second benefit is consistency. It ensures that the this keyword behaves consistently, making the code more predictable and less prone to errors. In conclusion, understanding how the this keyword behaves in different contexts is crucial for JavaScript developers. By using strict mode and being cautious of how methods are called, developers can write more robust and secure code. The implicit use of strict mode within class bodies in modern JavaScript helps enforce these best practices, preventing common mistakes associated with the this keyword in global context. What are the potential consequences of detaching a method from its object context in JavaScript? Detaching a method from its object context in JavaScript can cause the this keyword to lose its original reference. Instead of pointing to the object it belongs to, the this keyword may point to the global object, like window in browsers, or be undefined in strict mode. This can lead to unexpected behavior and bugs because the method no longer has access to the object's properties or methods. How does strict mode in JavaScript enhance code safety and consistency, particularly in the context of class bodies? Strict mode in JavaScript makes code safer and more consistent by changing how certain things work. In class bodies, it ensures that the this keyword is not accidentally pointing to the global object. Instead, if the this keyword is not set, it will be undefined, which helps prevent bugs. Strict mode also stops you from making some common mistakes, like creating global variables by accident, making the code easier to understand and less prone to errors. So understanding abstraction with the programmer class. Abstraction in programming involves hiding complex implementation details and exposing only the necessary parts of an object. This is commonly achieved through private properties and methods. Let's apply the concept of abstraction to a programmer class, where certain details like the programming language proficiency level might be internal to the programmer's operations. Let's consider the first approach, where we achieve private properties through the naming convention. So one approach is to use an underscore prefix to indicate a private property. So if we create a programmer class, and we have the constructor, taking a name and language, then we can do this dot underscore language assigned to language. I'll just add a comment here. It's not truly private, just a naming convention. So now, if we were to instantiate it, const programmer, new programmer, passing in Steven and the language of JavaScript. Here, if I log out, we do programmer.underscore language. So here it outputs JavaScript. So we still have public access, but the use of the underscore indicates to the programmer that this is supposed to be a private property. Now, there are issues with this. And the issue is that this method relies on the naming convention and does not provide true privacy. Properties are still accessible from outside the class. So let's consider a second approach, which uses ES6 symbols. A more secure way to implement private properties is using ES6 symbols, which provides a way to create unique identifiers. So before I create my class, I will say underscore language and set it to a symbol value, which is a unique identifier, a unique value. So rather than setting it through dot notation, underscore language, I'll use the square bracket notation, and I'll pass in the symbol as a key. Just to demonstrate this, this is more private, but still accessible through reflection. So here, if we try to access underscore language, that's not a property defined in it. So we can actually access this, but it is not straightforward. But to demonstrate how you could, I will log out, object.getOwnedProperty symbols. I'll pass in the identifier for our object. Let's save that. So here we see an array of symbols. So using this, if I want to get the value at the 0th index, I could do so. So if I want to access that value at the 0th index, I can say const language symbol is assigned to, and I'll just copy this value over, and the 0th index. So I can use this as the key in order to get the language. I do log, programmer, and then square bracket notation, the language symbol, and it outputs the value of JavaScript. So here we see that this property is still accessible through the outside, although it is not intuitive. So some observations. Symbols provide a pseudo-private mechanism as they are not accessible through normal property access methods. However, symbols can still be accessed through object.getOwnedProperty symbols, so it's not completely private. So let's consider private methods using symbols. Similarly, you can use symbols to create methods that are not accessible directly via the class instance. So let's say if I were to define a symbol, I'll say underscore code, and set that to a new symbol, so a unique value. Now, I can create a private method. So I'll use square bracket notation, then the symbol as the name of that method. And then let's log. I'll say this.name is coding in, and I'll say this _ language. And that with a period and a semicolon. So in conclusion, while symbols enhance privacy, they do not provide a foolproof solution for private properties or methods. For truly private class fields, ES 2022 introduces private class fields and methods using the hash symbol, or the hash prefix. So this is also called the pound symbol or octothorpe symbol, but I'll refer to it as the hash symbol. And this is the best approach going forward for ensuring data encapsulation and adhering to the principles of abstraction and object-oriented programming. So let me clear all this so we can start from scratch. I'll clear this out. Now we can say class programmer. Now I'll create a private property. We'll name it language. And here we see it is prefixed with the hash symbol. Now let's define our constructor, which takes in a name and a language. And we do this dot hash language is assigned to the language. And let's set the name to this dot name, this dot name. Now we can define a truly private method. We could do so with hash and then code. So we can just log coding in this hash language. So now let's create an instance of this class. So we're creating a new object in memory, programmer, passing in my name and the language. Let's log this programmer object. And when we output it, we can expand it and we see the name and the language. Now if we try to access the property of language, let's try doing that here. Programmer dot, if I do hash and then language, here we see the private field hash language must be declared an enclosing class. So in other words, it is not accessible. If we try to access it by language, we get the value of undefined. So this method ensures that the language property and code method are completely private, encapsulated within the programmer class, and not accessible from outside. This approach aligns closely with the principle of abstraction, keeping implementation details hidden and interfaces clean and straightforward. What are the benefits and limitations of using symbols for creating private properties in JavaScript classes? Using symbols for private properties in JavaScript classes has benefits and limitations. Now the benefits are improved privacy. Symbols make properties less accessible through normal methods, adding a layer of privacy. Another benefit is unique identifiers. Symbols create unique property keys, reducing the risk of naming collisions. Now the limitations. The first limitation is that it is not fully private. Properties created with symbols can still be accessed using methods like object.getOwnPropertySymbols. Another limitation is complexity. Using symbols can make the code harder to read and understand, as accessing these properties isn't straightforward. How do private class fields introduced in ES 2022 improve data encapsulation compared to previous approaches? Private class fields introduced in ES 2022 improve data encapsulation by providing true privacy for properties and methods. Using the hash prefix, these private fields are completely hidden from outside access, ensuring they can only be used within the class. This prevents accidental or unauthorized access, making the code more secure and easier to maintain compared to previous approaches like naming conventions or symbols, which didn't fully hide the data. So your exercise is to implement private properties and methods with ES 2022 in a grocery list application. In this exercise, you will create a grocery list class and a grocery item class to manage a grocery list application. The goal is to understand and apply the concept of abstraction by using ES 2022 private properties and methods. This will help you hide the implementation details and expose only the necessary parts of these classes. So let's do a quick overview of the instructions for this exercise. The first is to create the grocery item class. This class should have private properties for the item's name and quantity. It should include a constructor to initialize these properties, and implement a method to display the item details. This method should be public and provide a formatted string of the item's details. Second, create the grocery list class. This class should have a private property for the list of grocery items, include methods to add an item to the list, remove an item from the list by name, and display all items in the list, and ensure that the internal list of items is not directly accessible from outside the class. Now, the third instruction is using ES 2022 private properties and methods. Use the hash prefix to define private properties and methods in both classes. Ensure that no implementation details are exposed outside the class. So the example code, here is the starting point for the grocery item and grocery list classes. So we will create a grocery item class. So we'll have a constructor which takes in the name and the quantity. Now it will have a public method to display item details. So I'll name this display item. Now let's create our grocery list class. And I'll scroll up so we can see it better. So this will have a constructor. It will have a public method to add an item to the list. So we will name that add item, and that takes in name and quantity. We will have a public method to remove an item from the list by name. You can name that remove item, pass in the name as the parameter, and a public method to display all items in the list. You can name that display list. So this is our starting point code. So now the task checklist. First, define the grocery item class. Create private properties, name and quantity, implement the constructor to initialize these properties, and implement the display item method to return a formatted string of the item's details. Task number 2. Define the grocery list class. Create a private property, items, to hold the list of grocery item objects. Implement the add item method to add a new grocery item to the list. Implement the remove item method to remove an item by name. Implement the display list method to display all items in the list. The third task is to test the classes. Create an instance of grocery lists. Add multiple items to the list. Display the list to ensure items are added correctly. Remove an item and display the list again to ensure the item is removed correctly. By completing this exercise, you will gain hands-on experience with ES 2022 private properties and methods, enhancing your understanding of abstraction and encapsulation in JavaScript. So now for our grocery item, let's declare our private properties, which is name and quantity. Now we will set these private properties. So this hash name is set to name, and this quantity is assigned to quantity. Now to display the items, we can log, and actually I will have it return the value rather than log. So I will use backticks. I can say item, this, and then hash name, and then quantity, this, quantity. So we've implemented that class. Let's expand this so you can see it better. Let's scroll. Now we want to create a private property for our list of grocery items. So we'll name the items. And within the constructor is where we will initialize this array. So this items assigned to an empty array. And I'll scroll up. So for adding an item, I will create a new grocery item object. So item, new grocery item, passing in the name and the quantity. So now I will push to the end of the array. So items.push, adding that new item. So now for the remove method, say this items is assigned to this.items. We use the filter method. We pass in a callback function. This is a predicate. So the item dot display item, so that output here, which includes the name and the quantity. So if that includes, I'll use backtick, item, and then the name, then in that case, it would be filtered out in the case when it is not included. And now to display everything, I can say return this items.map, and pass in our callback item.display item. And I can say .join, and we'll specify a new line. So all the items will be displayed on their own line. So now, let's resize this so we can see our console. So now we want to create a new instance of the grocery list. New grocery list. Grocery list. Let's add some items. So .add item. So I'll say apples, the quantity of 5, and I'll do shift option down arrow. So just to add bananas, and we'll specify the quantity to be 3. Then we can call log grocery list dot display list. Let's save that. So here we see the expected output. So it's calling the display item method for each of them. So now let's remove an item. So I can say grocery list dot remove item. So remove apples. And then let's copy this, and we will call it again. So now let's say if I clear it and we run it again, we see for the first output is apples and bananas. And after we call the remove method, it successfully just displays what is left in our grocery list, which is bananas. WeakMap provides a way to securely store private data for an object without preventing garbage collection when the object itself is no longer in use. Here's how you can use WeakMap to implement private properties and methods within the programmer class. So let's define underscore language and instantiate a new WeakMap, and const underscore work new WeakMap. So this data type allows us to store key value pairs. So now we will create a programmer class. The constructor will take in a name and a language. So now we can set the name to be a public property, but in this case we want the language to be private. I'll just add a comment here to better describe what we're doing. So store language in a WeakMap with this as the key. So I can set underscore language dot set. So here we are set in the WeakMap. So for the first argument, we specify the object. So in this case, it would be the this keyword, which refers to this current programmer object. And we will specify the value being language, right? So the value that we pass in to the constructor. So now let's store a private method in a WeakMap. So underscore work, right? This WeakMap that we created up here, we will set the this keyword referring to this current object. And for the value, we will specify a callback function. So within it, we will log, use backticks, this.name is coding in, we'll do the WeakMap, which is named underscore language, dot get, and the this keyword as its key. So now we can save that. So now let's implement a method named code. So this is a public method, and this will call the private method that we have stored in the WeakMap. So I'll add a comment, access, and invoke the private method. So underscore work, which is the name of that WeakMap, call the get method, and we pass in the this keyword, so this current object, which is the key, and now we need to call or invoke this method. So open and closing parentheses to call that method. So now let's create an instance of this programmer class. So I'll say const programmer, new programmer with my name as Steven and the language of JavaScript. And let's call that public method code. And we save that, we see Steven is coding in JavaScript. So we call the code method, and this call the method defined in our WeakMap, which is a private method. So let's go over a discussion of the WeakMap data structure and the benefits and usage. So first is garbage collection. A major benefit of using WeakMap is its handling of keys. If there are no other references to a key object, in this case, an instance of programmer, it can be garbage collected. This helps prevent memory leaks in applications where objects are dynamically created and destroyed. The second benefit is encapsulation. Using WeakMap for storing private data ensures that these details are not accessible from outside the class. This is much more secure than using properties prefixed with an underscore, as these are only conventionally private. Third is arrow functions and the this keyword. Arrow functions do not have their own this keyword context. Instead, they inherit the this keyword from the enclosing execution context. Within underscore work, this refers to the programmer instance, allowing access to the instance's name and other properties securely stored in the WeakMap. So let's consider an alternative with a single WeakMap. You can also group all private properties into a single WeakMap entry per object, though this might make the code slightly more verbose. To show an example of that, let's comment out this implementation. We will create a new one. So I'll say const private props new WeakMap. So now we will create a new implementation of programmer. So the constructor takes in the name and the language. Let's remove that underscore. So our curly braces. Now we will say private props. Move this up. Dot set. So for the key, it is this current object, so that this keyword. And for the value, we will specify a JavaScript object. So here we will store key value pairs. So we'll specify the name, the language. So now let's specify the work method. So we'll specify a callback. So we will log backticks private props dot get the this keyword and the property of the name is coding in private props dot get the this keyword dot language. So now we'll implement our public method code, and this will call private props dot get the this keyword and calling the work method. So now when we output it, we get the same expected result. So in conclusion, using WeakMap for managing private data in JavaScript classes provides a robust way to ensure encapsulation and data security. This approach is particularly useful in scenarios where data privacy is crucial and helps maintain clean API boundaries within your classes. How does using WeakMap for private properties and methods enhance data encapsulation and security in JavaScript classes? Using WeakMap for private properties and methods enhances data encapsulation and security by ensuring that private data is not directly accessible from outside the class. This keeps the implementation details hidden, providing a secure way to manage private data within objects. What are the benefits of using WeakMap in terms of garbage collection, and how does this prevent memory leaks in JavaScript applications? WeakMap allows objects to be garbage collected when there are no other references to them, even if they have private data stored in the WeakMap. This helps prevent memory leaks by ensuring that memory used by objects no longer in use is freed up automatically. What distinguishes WeakMap from the ES 2022 hash syntax for private properties and methods, and why might you choose to use WeakMap? WeakMap allows you to store private data for objects without preventing their garbage collection when they're no longer in use, making it useful for managing memory efficiently. The ES 2022 hash syntax provides built-in support for private properties and methods, making them truly private and not accessible from outside the class. You might use WeakMap if you need private data that can be automatically cleaned up by garbage collection to prevent memory leaks. So we'll start by demonstrating how to store a private property in a programmer class using a WeakMap, and then show how to define property accessors. So let's set language to a new WeakMap, and we'll define a programmer class. So once again, we have our constructor setting the name and the language. Let's remove that underscore. We'll set the name and the language with the WeakMap. So this operator, or this keyword rather, for the current object, and the language. So this property is public, and this is private. Now we'll define a method named getLanguage in order to access this private property with a private value, which is the language. So we will return language.get and then this keyword. So we'll create a new programmer. So const programmer is assigned to new programmer, Steven, and the language of JavaScript. So now let's call the getLanguage method. We need to call the console log. So log, and then programmer.getLanguage. Save that. And we get the value of JavaScript. So now using object.define property to define a getter. For cases where you want the property to be accessible more like a property rather than a method, you can use object.define property. So rather than calling the getLanguage method, we prefer to access it through a property named language. So here we can set object.define property. So the first argument is this keyword, so this current object. Now we would name the property. So in this case, I'll name it to be language. And then we'll pass in an object. So use the get keyword. Set this to an anonymous function. And here we return language.get and this. Right, so we don't need this method anymore. Now we can access it through dot notation through this property that we created. So rather than doing getLanguage, you can access it with language, as that is the name of the property that we specified here. So now when we call it, let's clear it actually, and save it. We get the expected result, as this is calling this function defined here. Cleaner ES6 syntax for getters and setters. In ES6, getters and setters can be defined within the class body, providing a more concise and readable way to access properties. So let's delete here where we define the property, and let's define a getter. So we use the get keyword, and then space, and then the name of the property. So we'll name it language. And this returns, right? So we're using the WeakMap here, get, and then this keyword. So now let's define a setter. So we'll set the language. The parameter will be new language. Let's move this up. So if new language is falsy, in the case when it's an empty string, for example, then we'll throw an error saying language cannot be empty. And that with the semicolon. Otherwise, we will update the value stored in the WeakMap. So set. So the key is this keyword, so this current object, and we'll update the language. All right, so now we can access language as if it were a property. So here, let's clear this. When we save it, we get the expected result. So now let's update the language. So I can say programmer.language, and I'll set this to a new language such as Python. So let's scroll up. So let's log this out. Programmer.language. When I save it, here I see the value has been successfully updated to be Python. As when we set this value, so programmer.language is assigned to Python, we are calling this setter. Let's expand this, and I'll discuss it. So first let's consider the WeakMap, which we define here. This provides a way to securely store private data associated with an instance. So object.define property. This method is useful when you need to create getters or setters that appear like properties but are backed by methods. it allows for fine-grained control over property characteristics. ES6 getters and setters. These provide syntactic sugar that makes accessing and modifying properties intuitive and similar to accessing traditional class properties. This method is particularly useful for validation, logging, or handling side effects during property access. In conclusion, these different approaches allow JavaScript developers to encapsulate and protect data within classes effectively, ensuring that implementation details are hidden and that public interfaces are clean and easy to use. Using these features appropriately can help maintain and scale large codebases, making your code more robust and easier to manage. How do ES6 getters and setters enhance the encapsulation and control of property access within classes? ES6 getters and setters enhance encapsulation and control by allowing you to define methods that get or set property values. This provides a way to add logic when accessing or modifying properties, such as validation or transformation, while keeping the syntax similar to regular property access. What are the benefits of using the get and set keywords in ES6 classes compared to traditional methods for accessing and modifying properties? Using get and set keywords in ES6 classes allows for more intuitive and cleaner syntax for accessing and modifying properties, similar to regular property access. They also enable adding custom logic, such as validation, when getting or setting a property, enhancing encapsulation and control. So let's cover inheriting and extending the programmer class. We'll start with a base programmer class that has a constructor for initializing a programmer with a name and a basic method for coding. So we'll specify our class, and our constructor accepts a name. Now we'll just set this name property. And we have a simple method for coding. So this will log out, do backticks, this.name, starts coding. So we've implemented our base class. So now let's create a derived class, which would be a front-end programmer. So we will extend this general base programmer class to create a front-end programmer class that includes additional properties and methods relevant to front-end programming. So implement that just below it. So it will be class front-end programmer. And we'll use the special keyword extends programmer. So the derived class will inherit from the base class when we use the extend keyword. And this is because the front-end programmer is a programmer. So this is how you would achieve inheritance using the ES6 class syntax. So we inherit the properties and the methods from the base class. So let's create our constructor function. This accepts the name, and we'll specify an additional parameter, which will be tools. So we can call super and then name. And so this keyword, super, this calls the superclass constructor with the name argument. So we'll call this constructor of the base class. So let me add a comment here just to better describe that. I'll say calls the superclass constructor with the name. Now we'll set the tools based on the argument passed in. So I'll add a comment to describe this as well. I'll say additional property specific to front-end programmers. So now we will specify its own code method. So we'll say super.code. So this calls the generic code method from the programmer base class. And now we'll add additional functionality. So I'll log out, we'll use backticks, I'll say this.name, codes with, I'll say this.tools. We'll end it with a period and a semicolon. Let me extend this so we can see it better. So now we can add methods specific to a front-end programmer. So I'll say design. Let me scroll up so we can see. Now we'll log out, backticks, this.name, also designs the user interfaces. So here we see our derived class, front-end programmer, is a more specific version of the programmer base class and has additional functionality. So now let's use this derived class. We create an instance of the front-end programmer class, and we'll demonstrate the use of both inherited and specific methods. So I'll say const front-end dev assigned to a new front-end programmer. I'll pass in my name, and I'll specify the React JavaScript library as the tool. So let's resize it so we can see the output. And I'll say front-end dev, and we call the code method. And we save it. So here we see Steven starts coding and Steven codes with React. So that first log statement, Steven starts coding, is implemented in the general or the base programmer class. Right, that is because we called super.code. And then we see it outputs the log statement in the front-end programmer. So we resize it when it says Steven codes with React. So now let's call another method. I'll say front-end dev.design. Implement that. And here we see this log statement we specified here, which is Steven also designs the user interfaces. So let me expand this, and we can discuss it. So we covered inheritance. So the front-end programmer class inherits from the programmer base class, gaining access to its methods, while also being able to introduce new properties and methods or override existing ones, like how we did with this code method. We use the keyword for super, so the super keyword is essential for calling the constructor of the base class, so in this case the programmer class, from the derived class. It ensures that all the initialization logic in the superclass is properly executed before additional setup in the subclass. And we covered method overriding. The code method is overridden in front-end programmer to extend its functionality, but it also calls the superclass's code method to maintain the general coding behavior. In conclusion, this example clearly illustrates how to effectively use inheritance in JavaScript to create a hierarchy of classes, where derived classes extend and specialize the behavior of their base classes. This pattern is crucial for structuring complex applications in a way that promotes code reuse and logical organization. How is the super keyword used in the front-end programmer class? The super keyword in the front-end programmer class calls the constructor of the programmer base class, ensuring that the name property is initialized correctly before adding more properties or methods specific to front-end programmer. What are the benefits of using inheritance when extending the programmer class to create the front-end programmer class? Using inheritance to extend the programmer class allows the front-end programmer class to reuse existing code, add new properties and methods, and override existing ones, making the code more organized and easier to manage. Let's go over method overriding with ES6 Classes. We will start with a base programmer class that has a generic work method, then we'll create a specialized front-end programmer class that extends programmer and overrides the work method to add specific behavior. So let's implement our base class. So that will be a programmer. We'll implement the constructor to accept a name parameter. So this.name is assigned to name. Now let's implement the generic work method. So we'll say log and tab backticks. This.name is solving problems. So this is our base class, which we will extend. So we'll implement class front-end programmer extends the programmer base class because the front-end programmer is a programmer. So this accepts a name, and we call the superclasses constructor. So comment initialize the base class part of the object, and we will override the work method. So we'll call super.work. So this calls the base class method, And now we will add our own specific functionality. So I'll say log, say this.name is also designing and implementing UI components. So now let's use our derived class. Say const, I'll say Steven equals new front-end programmer. So it accepts a name parameter. So I'll pass Steven as the argument. Now we'll say Steven.work, and we'll save it. And here we see our expected output. So it calls super.work. So it calls the base class's implementation of the work method. So we see Steven is solving problems. And then we will log out. Steven is also designing and implementing UI components. So let's expand this. So understanding the method lookup and the super keyword. So method lookup. When a method is called, the JavaScript engine first looks for it on the object itself. If it can't find the method, it walks up the prototype chain to find the method in the parent class. So in this case, front-end programmer, its prototype or its parent is the programmer base class. And we're able to achieve inheritance through the extends keyword. So using the super keyword. The super keyword is crucial in subclass methods to call corresponding methods defined in the superclass. This feature allows subclasses to enhance or modify the behavior of methods they inherit without completely rewriting them, thus promoting code reuse and reducing duplication. In conclusion, by overriding methods and using the super keyword effectively, you can ensure that subclasses not only tailor inherited methods to their specific needs, but also leverage and extend the functionality provided by their superclasses. This approach is beneficial for maintaining logical and maintainable code in object-oriented JavaScript applications, as it minimizes redundancy and ensures a clear and efficient inheritance structure. What is method overriding in ES6 JavaScript classes? Method overriding in ES6 JavaScript classes is when a subclass provides a specific implementation for a method that is already defined in its parent class, replacing the parent's method with its own version. How does method lookup work when calling a method on an object in JavaScript? When calling a method on an object in JavaScript, the engine first looks for the method on the object itself. If it's not found, it checks the object's prototype and continues up the prototype chain until it finds the method or reaches the end of the chain. What is the role of the super keyword in a subclass methods in JavaScript? The super keyword in subclass methods in JavaScript is used to call methods from the parent class, allowing the subclass to build on or modify the behavior of those methods. So let's summarize what we covered in this section. ES6 Classes. We explored how ES6 class syntax provides a clearer, more concise way to define constructor functions and manage inheritance. Classes make the structure of object-oriented JavaScript cleaner and more similar to other programming languages, which helps in organizing code and improving readability. Hoisting. The concept of hoisting was discussed to understand how JavaScript interprets function declarations and variable declarations differently. We noted that function declarations are hoisted to the top of their containing scope, allowing them to be used before they appear in the code. Static methods. We learned about static methods, which are called in the class rather than on instances of the class. These methods are useful for utility functions that operate independently of class functions. The behavior of the this keyword in different contexts was examined, especially how it can vary depending on the scope and the manner in which functions are called. Private members using symbols. The use of ES6 symbols as a way to somewhat hide implementation details was covered. Symbols provide a way to create properties that are not easily accessible from outside the class. Private members using WeakMaps. We discussed using WeakMaps to securely store private data for objects, providing true encapsulation by ensuring that these details are inaccessible from outside the class and are eligible for garbage collection when no longer needed. Getters and setters. The implementation and benefits of getters and setters were explored. These are used to control access to the properties of an object, allowing for validation, logging, and other side effects when properties are accessed or modified. Inheritance. We covered how classes can inherit from other classes, allowing for shared behavior across different types of objects and reducing code redundancy. Method overriding. The ability to override inherited methods was demonstrated, showing how subclasses can modify or extend the behavior of methods defined by their superclasses. This section aimed to deepen your understanding of modern JavaScript features and best practices, enhancing your ability to write clean, maintainable, and efficient JavaScript code in a professional development environment.